Hey students, in this video we're going to be learning how to write fractions as decimals. I'll show you two ways of doing this. The first way is before people had calculators, they used to use long division to write a fraction as a decimal. That way it takes a lot longer. Usually the quickest way to do it nowadays is with a calculator. But I'll show you how to do both ways. And remember, with calculators, you can use any calculator you want, including a real calculator or virtual calculator. Even just the one that comes with your computer is good enough for this section. Okay, so let's do an example. Write each fraction as a decimal. Write each fraction as a decimal. Okay, problem number one. For problem number one, the fraction they're giving us is 21 over 25. 21 over 25. So the basic idea here is if you want to do these quickly, you want to use a calculator. But I am going to show you the old-fashioned way just on the first problem. Okay, so slow way. Method one. This way is slower. We use long division. Use long division. In most cases, you don't want to always do it this way because it's so slow, but this is how people used to do it before they had calculators. Okay, so I just wanted to show you how to do it. So using long division, we're doing, our numerator is 21, and our denominator is 25, so we're doing 21 divided by 25. Okay, and what we do here is to the right of 21, here's our decimal, and we bring our decimal straight up to here. Okay, and then we ask ourselves, how many times does 25 go into 21? Well, 25 does not go into 21, so we put a 0 to the left of the decimal point. So put a 0 there. Okay, and then since 25 does not go into 21, we add on another 0 over here. All right, and we ask ourselves, how many times does 25 go into 210? So this 21 now has an extra 0 here. So how many times does 25 go into 210? Well, I would say 8, because 8 quarters gives you $2, right? So 8 times 25 is 200. So we're going to put an 8 up here. Okay? And then we multiply 8 times 25. So 8 times 25, well, 8 times 5 is 40. Carry the 4. 8 times 2 is 16, plus 4 is 20. So we get 210 minus 200. Okay? And subtracting there, we end up just getting 10. Okay, so 210 minus 200 is 10. Now with long division, you have to keep going until you're completely done. Okay, so here, 25 does not go into 10, but what we do is we add another 0 here, and we bring down the 0. And then we ask ourselves, how many times does 25 go into 100? And everyone should know there's 4 quarters in $1, so 4 times 25 is 100. So we write a 4 up here, and then we do 4 times 25 is 100. And so we get 100 minus 100, which is 0. Okay? And once you get to 0 as your remainder down here, that means you're done with the long division. So that means 0.84 is our answer. Okay, so I'm going to circle that, or box that. 0.84 is called the quotient, which is the same as the answer to a division problem. And because 0.84 doesn't repeat and it stops, it's called a non-repeating terminating decimal. Okay, so this is a terminating decimal. It's called terminating. Terminate means it stops. So notice it's a terminating decimal because it stops at 4 and then it doesn't go on. And it's terminating decimal is what we're going to call it. And it's not repeating the same pattern, so you could also call it non-repeating. Okay, that's the old-fashioned way of converting fractions into decimals. It's fine with a problem like this, but as you can see, even with this problem, it took us a while to write it down. So let's talk about method 2, which is way faster, which is that you just type in the division onto a calculator and then it gives you a decimal. That's definitely the easiest way to do it, is method 2. Okay, so method 2, use a calculator. Use a calculator. So method 1 shows us how it works. Method 2 is fast. This is way faster. Okay, so what we would do is, rather than having to write anything down, we would just go to whatever calculator you have and type in 21 divided by 25. Okay, so you just type in 21 divided by 25, and then you press enter, or whatever your button is, equals, on your calculator. So for example, even the cheap calculator that comes with my computer, that's free with my computer, will do it. So 21 divided by 25 gives me 0.84. That's definitely the quickest way to do a decimal. And that actually converts a fraction directly to a decimal, and it's almost instant, so definitely fast. But as you can see, you get the same answer. You still get 0.84, and that's still a terminating decimal because it doesn't keep going on forever. It stops, so it terminates. Okay? So hopefully that's not too bad. Alright, so I wanted to see a couple more. These are usually pretty easy for people, for the most part. Okay, so let's see problem number 2. Problem number 2 is negative 13 over 20. So from now on, I'm just going to be using method 2 to save time. Remember, if you have a single minus, that means that your answer is going to be negative. If you have two minuses, they cancel out and become positive. But if you just have one minus, that means your answer is going to be negative. And then 13 over 20, we can just go to our calculator and type in 13 divided by 20. And that gives us 0.65. But remember here, because there's a minus out front, it's actually going to be negative 0.65. And this is another example of a terminating decimal. It's called terminating because it ends. Okay. So that's not too bad. All right, and most of your homework is pretty straightforward. It's just when the decimals start to repeat that gets a little bit more challenging. Okay, so you'll see what I mean in problem number 3. Okay, so problem number 3, we have negative 11 over negative 12. Negative 11 over negative 12. So here we have two minuses, and remember, if you have two minuses when you're multiplying or dividing, they cancel out and become a plus. Okay, so we can cross out those two minuses, and so we know our answer is going to be positive. Okay, and then once again, the easiest way to do this, the quickest way to do it, is to just do 11 divided by 12 on any calculator. Okay, so let's do 11 divided by 12. Now this gives us an interesting situation. So here, notice it gives us a lot of digits, and a lot of these digits are just repeating. So it says 0.916666666 goes on forever, and then at the end it has a 7. That 7 there at the end is just because they rounded at the end. It's actually going to go 6 all the way, but they rounded the last digit on this calculator. Okay? So 6 actually repeats forever. So it's what's called a non-terminating, because it doesn't end, decimal. And it's also called a repeating decimal, because it's repeating the 6 over and over again. Okay, so what we got was 0.916666, etc. So the 6's just go on forever. Okay, and I wrote 3 dots to show that the pattern just keeps going. So the 6's are repeating forever. But that's not actually how you're supposed to write your answer. Okay, what you're supposed to do is you're supposed to look at whatever is repeating. And here we can see the only thing that's repeating is the 6. And whatever is repeating, you put a bar over it, a horizontal bar. So we actually write this as 0.916. And then because the 6 is repeating, we put a bar just over the 6. Okay, that's putting a bar over what's called the repeat end. The repeat end is what repeats over and over again. Okay, and because this decimal goes on forever, it never stops. This is called non-terminating. Remember, terminating means it stops, so non-terminating means it never stops. It's non-terminating, but it's also repeating, because you can see it's repeating 6 over and over and over and over again forever. We say it's non-terminating, but then it's also repeating. So it's a non-terminating, repeating decimal. So it does not stop, and it repeats, so that's how it gets its name. And remember, whatever is repeating, whether it has 1 digit, 2 digits, 3 digits, whatever you see is repeating over and over again, that's what you put the bar over. The bar only goes over whatever digits are repeating over and over again. Okay? Cool. Okay, so the next thing I wanted to talk about is actually rounding decimals. So as you can see, converting decimals to fractions, converting fractions into decimals is pretty easy. But we're going to be talking about rounding decimals because that's also important. And it's also pretty easy as well, but it's a slightly different topic. Okay, so example. Convert 8 over 93 into a decimal and then round, so they want us to round it this time, to the nearest hundredth. Round to the nearest hundredth. Okay, so let's start with the part where we convert it to a decimal. So to convert 8 over 93 into a decimal, we're dividing, and again, the easiest way to convert it to a decimal is on a calculator. Okay, so 8 divided by 93 gives us this long decimal. So here, if you look at this decimal, there's not really any repeating pattern. So this one has a lot of digits, and it just keeps on going. So it's like 0.086021, etc. 0.0826, what did I say? I already forgot what I said. 0.086021. And it just keeps going. 505,376. 505,376, etc. I'll just put a ... to show that it goes forever. But notice there's no pattern here. So if it's repeating, it has a lot of digits and we can't see a pattern. So since we don't see any pattern here, we don't see anything that's repeating, this is actually a non-terminating and non-repeating decimal. Okay, so this is a non-terminating because it doesn't stop, but it's also a non-repeating decimal. Actually, I just realized something. I'm wrong. It actually is a repeating decimal. We just can't see it repeating here. I know looking at these digits, we don't see any pattern that's repeating. However, it turns out that if you can write a number as a fraction, it's automatically going to be a repeating decimal. So I take back what I said. Sorry. So it's actually a repeating decimal. I'll take that back. And the reason it's a repeating decimal, even though we can't see it repeating, is any number that's represented as a fraction is automatically a repeating decimal. But I know it seemed to me like there was no pattern, but there probably is a pattern. It's just very, very long. Okay. So again, how do we know it's repeating? Any number that can be written as a fraction, is repeating. It's a repeating decimal. So that's a little technical detail that I had kind of forgot about, so I misspoke. This actually is a repeating decimal, even though we can't see the pattern. If we had a calculator that showed, 100 digits or 200 digits, eventually we would see a group of numbers that were repeating over and over again. Okay, but fortunately they didn't want us to write all these digits. They actually just wanted us to round to the nearest hundredth. So which ones are hundredths? Well, let me zoom in a little bit here. Actually, let me zoom in a lot. And I'm going to erase this, give myself some room. Okay, so just in case you don't remember, the way digits work is to the left of the decimal point, it's tens, hundreds, thousands, 10,000s, 100,000s, millions, and so forth. And to the right of the decimal, it's the same pattern, but you have a th after it. So like the 0 is tenths. So 0 is tenths. The 8 is hundredths. Hundredths. The 6 is thousandths. Okay, and then the 0 here is actually 10 thousandths. And then after that, you've got 100 thousandths, 100 thousandths, and then the one after that is millionths. So it's the same pattern as if you were going to the left of the decimal point over here. It's just as you're going to the right, it has a TH after it, but it's still the same pattern. So it's tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, and then I think you can imagine the rest. 10 millionths, 100 millionths, billionths, 10 billionths, 100 billionths, trillionths, and so forth. But we won't need to go that far here. Okay? So all we really have to do is round to the nearest hundredth. That's all they ask for. So here the nearest hundredth is going to be the 8. Right, so that's the one that they're talking about here. That's hundredths. Okay. All right, so we have, we want to round to the nearest hundredth, and since that's the digit there is an 8, we want to look at the next digit. And remember, when you're rounding, if the next digit is 5 or more, you round up to the next digit. So you round up to the next number. Otherwise, if it's 4 or less, you round down. So the saying is 5 or more, up the score. 4 or less, staying is best. Okay, so 5 or more, up the score. 4 or less, staying is best. So what we're going to do is we're looking at 0.086. That's the only part that we're looking at. This is the digit we're rounding. The next digit is a 6. So since it's 5 or more, we up the score. Okay, so it's actually going to end up becoming 0.09. Now if it were 4 or less, staying is best, which would mean it would stay as 0.08. But 0.09 is our answer.